Well, I am Anudev, and this is a session on handwritten digit recognition. So, import the initial libraries numpy, matplotlib, .pyplot for the plotting of charts, and from TensorFlow imported keras dataset, MNIST dataset, lot data, and here we have the data. We call the data as lot data, and we take the shape of the data. It's 2 by 2 matrix, and this is how we represent train images, train labels, test images, test labels as data. Now we have the unpacking data. Here we can see the unpacked data. So this is the first index, train labels. With index 0 gives the first index, so it's 5, and we can see the training labels here. So we have now we print the maximum pixel and minimum pixel values of the training images, and we can see it's 255 and 0. Now we have the shape of training data, that is 60,000 samples. Just each training sample is 28 by 28. Now we have this for the index 0. We can see this image pattern. Now we display images along with its label. So we use the PLT function, and we give the figure size as 10 cross 10. For I, we want to display the display 5 numbers, and for that we give range of 5, and we use the function imshow, and we plot to binary to have the grayscale images, and we get the X labels. We have this images along with the labels representing them. Now we have this training image data. Now this is before scaling. Now we scale it, dividing it by 255, and we have the scale data there. We use a sequential function, 3 layers. First one flatten input and the shape, that is 2888. Then we use activation sigmoid function to give second layer 128 activate points, and the second layer with 10 points activation of softmax. Now we have to place hidden layer and output layer, and we give the label as 1 for the hidden layer, and we print the shape of the weights and the base shape. You can see for the hidden layer it is 784 per 128, and the shape of the base is 128. Now we go for the output layer and give index as 2. You can see it's 128, 10 and 10. Now we use the function std optimizers. So this is the learning rate, this is the decay rate, and the momentum, the speed at which the function is moving on. Compare it, we have the loss function as sparse categorical cross entropy, and matrices as accuracy. And now use the fit function to train the data. 54,000 samples are trained and validated on 6,000 samples. We can see that we give the epoch value as 10, and 10 recurring is done. The batch size and validation split is 0.1. You can see the accuracy increases from 94.25% to 97.83 after the 10 functions. We have the validation loss and the loss function. We have visual representation using line, and we give the figure size as 10 5 10 5. Now we use the red color to plot the validation loss, and the green label to loss function, and you can see it reaching the point, and loss function is reduced. Now we check the accuracy and we get the accuracy as 97.48. Use the predictions model predict test images. Use the function plot confidence whose parameters are images, labels and predictions. We give the figure size as 1530, and using subplots we give the spacing between columns, lines and from bottom and top. We give the initial value of index as 0 and take the image index and plot index plus 1. Initially we have given the value 0 and we increase it, and we have the subplot function. Take 3 parameters, the image position, length of the image and the columns and plot index. And now we use the function imshow to view the image and plotting it to binary. Correct label is we print the correct label using the label of that column, and the predicted label we use where we get the maximum argument from the predicted bar chart. And here we explain the title. If predicted label is not equal to correct label, that is if predicted label and correct label have a mismatch, then there will be a background color of red, and if it is in match then the background color will be green. Give empty x ticks y ticks. Now we plot index and using subplot. Now we plot the bar chart in change of 10 and shows the prediction. Now we take 10 parameters and test 10 samples and test it using images equal to test images and 10 labels. We also use 10 predictions. We have the confidence here. It is plotted in 1 and we can see this parameter correct label and the predicted label when it have the maximum confidence. And here we have an error value as the confidence is more for the value 6 rather than the correct label 5. Now we have to visualize the correct indices. We plotted an empty list in the range of predictions. It is the argmax value of prediction I, that is the maximum value, and number of incorrectly classified images as the incorrect indices. And we produce the 10 incorrect indices. If I is an incorrect indices and incorrect label and incorrect predictions. Now we plot the confidence with incorrect images along with incorrect images and incorrect labels, incorrect images, incorrect labels and incorrect predictions. And this is machine learning used to recognize handwritten digits. Thank you.